Hi everyone, welcome back to Economics per se. We are starting a new chapter today on the classical theory. The first topic is going to be national income. It's going to be a long chapter, but for me it's super fun and I hope it is for you as well. Let's start. We learned from the last video that GDP measures both the total output and the total income of a country. The significance of GDP can be understood just by looking at international data. Countries with higher GDP tend to have a better standard of living on average compared to countries with lower GDP levels. Now, to find the sources and the uses of GDP, we must turn again to the circular flow diagram we discussed in the first chapter, but this time it will be a slightly more realistic version showing the linkages between economic actors. Now, households receive income and use it to buy goods and services, pay taxes, and to save. Firms receive their revenue from the markets for goods and services and uses it to buy factors of production. The reserves in the financial institutions are used to invest in goods like houses and plants. Governments uses the revenue they receive from taxes to buy goods and services, or to, if anything is left, they save it, calling it public saving. Public savings can be positive, as in a budget surplus, or negative, a budget deficit. Now let's talk about what we'll be discussing today and in the following video. We'll first start with firms and see what determines their level of production. And since total output is GDP, and GDP also means income, we are also looking at national income. Then we will see how and in what form the market for factors of production distribute this income to households. Then we will see how much of this income people save and how much of it they spend. We'll also discuss demand arising from consumers as well as demand from investment and government expenditure. Lastly, we'll see how demand for goods and services, which is the sum of consumption, investment, and government expenses, equals the supply of goods and services, which is Y. Now notice that we don't have an X here as we did in the previous video, and that's because we are assuming our economy to be closed, meaning no trade, no exports, no imports. You'll be learning more about that in the Microeconomics videos. Alright, let's get started. What determines the total production of goods and services? Well, the output of an economy depends on two main things: the quantity of inputs, called the factors of production, and the economy's ability to turn inputs into outputs, which will be represented by a production function. Factors of production are the inputs needed to produce goods and services, and the two most important ones are capital and labor. Capital are tools that workers use, like a computer or a crane, and labor is the time workers spend working. We use K to denote capital and L to denote labor. And now, in this chapter, for the sake of simplicity, we're going to assume that the economy has a fixed amount of capital and a fixed amount of labor, denoted by K bar and L bar. The bars here denotes that the amount of capital and labor are constant or fixed. In a later chapter, we'll see what happens when capital and labor vary over time, as they do in real life. We also assume here that the factors of production are fully utilized and that there is no wastage. Again, if this were true in real life, there wouldn't be any unemployment. Moving on, let's now discuss the production function. The technological level determines how much output can be produced from a given number of inputs. Economists use a production function to express this relationship. Denoting Y to be the level of output, we write the production function as Y is equal to F, K, and L. This states that output is a function of the amount of capital and labor used. So if someone invents a better way to produce something, the result is more of that good with the same number of inputs. Technological change alters the production function. Now, although we won't be using this at the moment, I'd like you to familiarize yourself with something called constant returns to scale. Many production functions have this property. A production function has constant returns to scale if an increase of an equal percentage in all factors of production causes an increase in output of the same percentage, meaning we get 10% more of output when we increase both capital and labor by 10%. We'll see this later in a different topic. Now, in this chapter, since we assume that supplies of capital and labor and technology are fixed, output is fixed as well. So, y is a function of k and l, and since k and l are both fixed, we'll say that y bar is equal to f of k bar and l bar. The changes of these inputs and the effects of those changes on the output will be discussed in a later chapter. Now, next question. How is national income distributed to the factors of production? Well, from the circular flow diagram earlier, we saw that income flows from firms to households through the markets for factors of production. But more precisely, we're going to look at a theory called the neoclassical theory of distribution. This theory combines the classical 18th century idea that prices adjust to balance supply and demand with the 19th century idea that the demand for each factor of production depends on the marginal productivity of that factor. This theory is accepted by most economists as the best way to start to understand how income is distributed from firms to households. We start with factor prices. Factor prices are the amounts paid to the factors of production. The distribution of national income depends on factor prices. If the two factors of production are capital and labor, the factor prices are the wage that the workers earn and the rent paid to the owner of the capital. Drawing a diagram, we can illustrate that the price each factor of production receives for its services depends on the supply and demand for that factor. So let's draw the diagram. On the x-axis, we have quantity of labor, and on the y-axis, we have factor prices. Factor supply is going to be vertical, and I'll talk about y in a little bit, and this is going to be factor demand. This point here is equilibrium factor price. Now, since we assume that the economy's factors of production are fixed, the factor supply is vertical. So regardless of the price, the amount supplied is the same. It doesn't increase nor decrease. The intersection of the demand and the supply gives us the equilibrium factor price. Now, we obviously have to examine the demand for the factors of production as well. We start by looking at the decisions a typical firm makes about how much of these factors they need. The simplest assumption to make is that a firm is competitive. A competitive firm is small relative to the market it is in, so it cannot influence market prices. The competitive firm takes the prices given or determined by the market. We assume we use the same production function for the firm as we did for the aggregate economy, which was y as a function of k and l, where now y is the number of units produced and k is the number of equipments used and l is the number of hours worked by the workers the firm has. If technology is constant, the firm increases output only if it uses more machines or if its employees work more hours. The firm sells its product at price P, hires workers at wage W, and rents capital at rent R. Notice we see that the firm's rent capital, and we assume it is owned by households for simplicity. We'll discuss that more in microeconomics. Now, the goal of the firm is to maximize profit. And profit is just equal to revenue minus costs. But now the question is, what is revenue, what are the costs, and how can we calculate the profit? Revenue is simply price times the quantity of output. So So revenue is simply the price times the quantity. Costs include both labor costs and capital costs. And labor cost is the wage times the labor. We'll call this WL. What is capital cost? Capital cost is rent times capital. Capital cost is simply rent times capital. This is K, and we call it RK. So we can write profit from this. Profit is going to be equal to revenue minus costs. So that means profit is equal to revenue, which is price times quantity. We'll call this PY, minus the costs, which is WL, minus the other cost, which is RK. Since y is equal to f of k and l, we can substitute f of k and l in for y to get profit to be equal to price times f of k and l minus WL minus RK. This shows us how profit depends on the factors of production. Okay, we now know what a competitive firm's goals are, maximizing profit. It's time for us to look at what determines a firm's demand for factories. We know that the firm is going to hire workers and rent capital to maximize profits, but what are those levels? Let's look at labor first and then capital. Well, the more labor the firm employs, the more output it produces. The marginal product of labor, the MPL, is the extra unit of output the firm gets from one extra unit of labor, holding the amount of capital fixed. As a function, we can write that MPL is equal to f of KL plus 1 minus f of KL. So this equation states that the MPL is the difference between the amount of output produced with L plus 1 units of labor and the amount produced with only L units of labor. But before we get jumpy, we have to understand that most production functions have the property of diminishing marginal product, meaning that holding the amount of capital fixed, the MPL decreases as the amount of labor increases. It's the same idea as the adage which goes, too many cooks spoil the broth. With just one pot cooking just one dish, the more cooks you have, the lower their individual productivity is going to be. Let's illustrate this with a diagram. Now, we have our graph. The x-axis represents labor again. Y-axis, we have y, which denotes output. This is our production function curve. F of k, which is fixed, and L. Our MPL, and MPL. Now this graph shows what would happen if we fix the amount of capital and varied the units of labor. We can see that the MPL is the slope of the production function. As the amount of labor increases, the production function becomes flatter, indicating diminishing marginal product. I'm sure you learned that in your Microeconomics class. Now, from the MPL is where we can derive the demand for labor. When the firm is deciding whether to hire an additional unit of labor, it considers how this decision would affect profits. This means the firm has to compare the extra revenue generated from the increased production with the extra cost of the higher spending on wages. The change in revenue can simply be calculated as price times the MPL. This is the change in total revenue. And well, this happens because the extra unit of labor produced MPL units of output, and each output sells at price P. The extra cost of hiring one more unit of labor is W. So let's say the change in labor cost is W. Now, The change in the profit can be written as, let me just erase this. Alright, now since we have the change in total revenue and the change in cost, we can signify we can denote the change in profit by delta pi is profit, minus, which is equal to change in total revenue minus the change in cost. And now we know what change in total revenue is. It's going to be price times the MPL. We know what the change in labor cost is. It's going to be W. So we can answer the question, how much labor should the firm hire? If the extra revenue, price times MPL, exceeds the wage, W, then an extra unit of labor increases profit. So the firm would continue to hire until the next unit of labor is no longer profitable, which means till the point where the extra revenue is equal to the wage. The competitive firm's demand for labor is determined by price times MPL being equal to the wage. Which can also be written. This can also be written as MPL is equal to W over wage over price. And this is the real wage. The real wage is the payment to labor measured in units of output rather than in dollars. To maximize its profit, the firm hires up till the point at which MPL is equal to the real wage, until this point. If the real wage is higher than the MPL, it would mean that the firm is giving, for example, 2 burgers to the worker for producing 1 burger. The MPL depends on the amount of labor employed, holding the amount of capital constant. Now let's try to draw that graph. So again, on our x-axis, we will have the units of labor as always. Labor down here, and y-axis has output again. This is our MPL curve. This is the quantity of labor, and this is the real wage. So what's happening here? Here we graph the MPL schedule. Because the MPL diminishes as the amount of labor increases, the curve is downward sloping. For more on MPL schedules, you'll learn about demand schedule and supply schedule and MPL schedule in microeconomics. The firm here will hire up to the point at which real wage equals the MPL at the intersection point. And that's it. The MPL schedule is the firm's labor demand curve. I guess that's all I have for you today. Next week, we will continue on this topic, discussing marginal product of capital and capital demand, the Cobb-Douglas production function. We'll look at what determines demand for goods and services and what brings the demand and supply of goods and services at a balance. Please leave a like if you have comments. See you next time.